Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 7. This is Section 11.1, Problem number 7. It says, consider the function f of x equals x squared minus 5x plus 6 over x squared plus 3x minus 10, and then find the limit as x approaches three different values. That'll be part A, part B, and part C of the problem. So for part A, you want to find the limit as x approaches 0 of x squared minus 5x plus 6 over x squared plus 3x minus 10. Now, what I want to do first is just see if I can put in a 0 for x and see if I zero out the denominator, which would make it undefined. And I do not zero out the denominator, so I can actually do that. Now again, in reality, when I take a limit, I'm not really putting in this number, 0 in this case. I'm putting in input values really close to it. But if I can actually put it in and have the function defined, what I'm getting when I put in the value that I approach and put in values really close to it, which is what the limit is, will be the same. So in the numerator of the function, x squared becomes 0 squared minus 5x, or 5 times x becomes 5 times 0, and I have plus 6. Then as I move into the denominator, x squared becomes 0 squared, plus 3x is really 3 times x, so 3 times 0, and I have minus 10. And now as I put in the 0, parts of the function just zero out. Anything that had a 0 in it becomes 0. And I'm left with positive 6 over negative 10. So I can reduce that. They're both evenly divisible by 2. And I get negative 3/5. So that's the value of the limit. As I put in input values that are really close to 0, I'm getting outputs that are really close to negative 3/5. And again, that output means it's the height on the graph that you would hit if you graph the function. So now part B, to take the limit of the same function as x approaches 1. So I want to take the limit of x squared minus 5x plus 6 over x squared plus 3x minus 10 as x approaches 1. So again, what I want to see first is, can I actually put in a 1 and see what would happen? Is the function defined at 1? And it turns out that it is. The denominator will not zero out, so I can just put in a 1 and see what happens in terms of taking the limit. Again, in reality, I'm not really putting in a 1. What I want to find out is what happens as I put in things really close to 1, like 0.9999. But by putting in a 1, which is much easier to do mathematically, I can get my answer. So in the numerator, x squared becomes 1 squared. Minus 5x is minus 5 times x, which in this case will be 5 times 1. And on the end, I have plus 6. And then in the denominator, x squared becomes 1 squared. Plus 3x is really 3 times x, which in this case will be 3 times 1. And I have minus 10 on the end. Now as I simplify this, 1 squared is 1. Minus 5 times 1 will be minus 5. Plus 6. And then in the denominator, 1 squared is 1. Plus 3 times 1 will be plus 3. Minus 10. So on top, I have 2. I can combine the positives. 1 and 6 is 7, and I have 7 minus 5. So 2 in the numerator. And then in the denominator, 1 plus 3 is 4. And then 4 minus 10 is negative 6. Don't lose the negative. And 2 over negative 6, I can reduce that and get a negative 1/3. So that's the limit. And again, what that means is, as I put in values really close to 1 as input values, the output is getting really close to negative 1/3. And finally, part C. Find the limit of the same function, x squared minus 5x plus 6 over x squared plus 3x minus 10, as the input approaches 2. So, like parts A and B, I want to first see if I can just put in a 2 for x and if it would be defined. And it turns out that it's not. If I try and put in a 2 for x, it's going to be 4 plus 6 minus 10. So 4 plus 6 is 10. So I have 10 minus 10. The denominator zeroes out. So the function is not defined at 2. I have to come up with some sort of a trick. So the trick is going to be to factor this to cancel part of it out. So I want to take the limit as x approaches 2 of let's see. What I'm going to want is, since putting in a 2 is what's getting me into trouble, I'm going to hope that one of the factors is x minus 2. So let's see if that'll work. So I want to factor x squared plus 3x minus 10 in such a way that one of the parentheses has an x minus 2. So I'd have an x in the other parenthesis. 5 would do it. Now if I look at the signs, it should be a plus 5. So again, if you FOIL out x minus 2 times x plus 5, it will give you back the x squared plus 3x minus 10 that was in the denominator of my function originally. So that can be factored that way. Then the numerator, x squared minus 5x plus 6, I will hope can be factored in such a way that one of the factors is x minus 2. That's going to be my goal. So try it. So I start with an x minus 2 in parentheses. Next to it I have another set of parentheses. I'm going to have x plus something or minus something maybe. And as I look at the numbers, if the other parenthesis is x minus 3, it will work. And again, you can FOIL out x minus 2 times x minus 3, do the math, and it will give you back the x squared minus 5x plus 6 that was in the numerator. So now that I have the function factored, it has an x minus 2 in the numerator and an x minus 2 in the denominator, so those can be canceled. And now I'm basically taking the limit as x approaches 2 of x minus 3 over x plus 5. Now I can put in a 2 for x because the function would be defined when I do. The top of the function, or numerator, x minus 3 becomes 2 minus 3. And the denominator of the function, x plus 5, becomes 2 plus 5. And in the numerator, 2 minus 3 is negative 1. Again, don't lose the sign. In the denominator, 2 plus 5 is positive 7. I get a negative 1/7. So again, even though I cannot actually put in a 2 in this function, the x squared minus 5x plus 6 over x squared plus 3x minus 10, I can put in values that are really close to 2. And the output that I'm getting is getting closer and closer to an output of negative 1/7. And again, what the output is it's the height up or down on the graph when you draw the function.